All right, so when I say Pythagoras, now this is written in Star Wars writing, and it's written the way Yoda would say it, because I'm a super nerd. The theorem Pythagorean, must you know. Some of you get that joke. I have found out recently, yeah, get in here and sit down. Get here on time. I have found out recently that there is more and more people every single year of your age that have no idea who Yoda is. That shocks me. It hurts me. It scars me to my very core. If you do not know who Yoda is and why I have written this way in Star Wars font, that is your actual homework for tonight. Because knowing who Yoda is infinitely more important than knowing how to do trig. I'm just kidding. You have to know how to do trig. But you're in summer school. You have to know how to do trig. But you have to. Understand? Because in real life, trig is important. Okay? All of you are going to do a job that requires you to do trig every single day of your life. Some of you are going to have a job that requires you to do trig every single day of your life. And every one of you should be able to do trig, because if you don't do it, you will hire somebody else and they will do it, and they will think that you don't know how to do the math, and they will rob you blind. Understand? All right. So let's move on. When I say the Pythagorean theorem, all of you say what? A squared plus B squared equals C squared. Every single one of you says that, because that is what you were taught. You've all been taught that. I got it, nailed. Until I do this. I draw this triangle. I call that side B, and I say that's 4, and that's 3. And I say, tell me how long B is. How long is B? Of course it's 5, because you know it's a 3, 4, 5 triangle. But if I said this, 27 and 18, now all of a sudden it's a little harder, because you got to use the equation, right? What's wrong with the equation and the triangle the way I've drawn it? B is where the hypotenuse is, right? And I have taught math for 20 years now, and every year I do this question. Every year half the class does it wrong. But it's B. Everyone see the problem here? That is why I do not like where the heck is it? I want my little dot back. I want my dot back. I'll get it back later. That is why I do not like teaching Pythagoras A squared, B squared, C squared. Okay? What I like to teach Pythagoras as is over here. And, okay, I can't deal with this without my light. Without my stupid pen lighter. Frustrating. It's supposed to always be running. I don't know why it isn't. There it is. Yay, it's back. Okay. I don't like teaching Pythagoras this way. I like teaching Pythagoras this way. The hypotenuse. Everybody says, what do you know about the hypotenuse? There's 30 of you. Some of you know something about the hypotenuse. It's the longest side. How do you know it's the longest side? Did you measure it? No. So you know it's the longest side, but when do you know it's the longest side? You have to do one of two things before you know it's the longest side. What are the two things you would have to do? One, you could measure all three sides, yes? And then the longest one would automatically be the hypotenuse. Agreed. What else? What's that? If you do the Pythagorean theorem and you get a longer side, you know it's the hypotenuse, yes? How do you know, what do you know about the hypotenuse without measuring it and without doing any math? You should be able to tell me on this drawing where the hypotenuse is. Where is it? Thank you. The hypotenuse is across from the right angle. Now, when we use the word across in English, we know what that means. But in math, across means opposite. The word opposite means you are crossing the shape. Always. Now, the reason I'm making a big deal out of this is sometimes I'll turn triangles this way. And kids will say to me, and this is honestly true, I don't know how to do Pythagoras there. When I turn it sideways. They'll say, I don't know where the hypotenuse is anymore. Some of you are looking at me like, who would be that dumb? And some of you are looking at me and saying, yeah, I can't do it then. It's true. Here is what you do. The little symbol always points to the hypotenuse. Always, no matter what. Here's the next thing. I'll draw a triangle like this. And kids will say, I can't do that. I'll say, why? Because that's not 90 degrees. Because it isn't drawn like 90 degrees. Is that 90 degrees? Yes. What makes it 90 degrees? That little symbol. Doesn't matter what it looks like. If that symbol's there, it's 90 degrees. Now, is that a 90-degree triangle? Can I do Pythagoras on the triangle I just drew? Yes or no? You got a 50-50 shot. Somebody take a guess. No, you cannot. Why? It's not a 90-degree triangle. Now can you? Once I put those numbers on there, what do you know about that corner? That it's 90 degrees, so you could add that in. Does everybody understand? Sweet. Okay. So the hypotenuse right across from the right angle, and the legs are the other two sides. And they are interchangeable. It doesn't matter which one is A and which one is B. The other thing that makes kids have problems, sometimes I'll label these with weird letters. QRS. And kids will actually say to me, I can't do Pythagoras anymore. I know that this boggles your minds because you're all very intelligent young people, but I have taught many kids that if I did QRS, they would say, how do I do Pythagoras then? There's no A, B, and C. That wouldn't affect any of you, would it? Would it? Of course not. So, let's prove it. Here are two triangles with no A, B, or C written on them. Tell me how long the missing side is. I would say find X, but then there's always some wise ass that says, there it is. Get it? Find X. There it is. Never mind. Just tell me the value of X in both of these. Go. This is a test for two things. One, it's a test to see if you know how to do Pythagoras without A, B, and C. And two, it's a test to make sure you know how to work your calculator. What's the first one? 17. And you found that, of course, because it was the square root of 8 squared plus 15 squared. Why was it plus? Because I sought the hypotenuse. Over here, what's this guy's x? Just one decimal is all I need. 8.9, because of course it was 12 squared minus 8 squared. It's minus because I needed a leg. Everybody cool? All you should be cool with this. You learned Pythagoras in what, grade 7? Everyone should be able to do Pythagoras in their sleep with any letters whatsoever, in any order, no matter how I twist the triangle around, no matter how I draw it. Every one of you should be able to do Pythagoras literally left-handed, underwater, with your eyes closed. Okay? Okay. Let's take a moment. I'll tell you a quick funny story. When I learned Pythagoras in grade 7, my teacher said, if you can't remember the word for the longest side, hypotenuse, he said, you can remember the word hippopotamus. And I said, all right, because I like hippopotamuses. Who doesn't, really? We get to the test. One of the questions on the test, what's the name of the longest side in a right angle triangle? Do you think I can remember the word hypotenuse? No, so what did I write? Hippopotamus. Guess what the teacher gave me? How did he mark it? Wrong. He took away a mark. He told me to remember the word hippopotamus. And to this day, I harbor a grudge against Peter Bailey. That was his name. I don't really, Mr. Bailey, you were awesome. He was totally an awesome teacher, except for hippopotamus. He's probably dead now, though, to be fair. I was in grade 7 in 1987. And he seemed old at the time. But when you're 12, everyone seems old, right? You guys all think I'm old. I'm only 43, but you think I'm old. You're like, holy crap, I hope I never get as old as that guy. It's not so bad still because a lot of your parents are still in their 40s, so it's okay. But in 10 or 20 years, when I'm teaching kids your age whose parents are in their 30s and 40s and I'm in my 50s and 60s, then it's going to be weird for me. But right now it's okay. Some of my first students I ever taught now, though, have children. A couple of the first students I ever taught have grandchildren, which is a little weird for me. But I'm working with it. I got some distance from it now. I'm okay. I taught in some very small schools in some very small towns. There's not a lot to do. So, all of you now look at that very first question and tell me, talk to your neighbor, tell me if you can find the value of x for me. If you can find it, find it. If you can't find it, tell me why. Go. I'll change that slightly. If you can't find it, fix the drawing so you can find it. You are not allowed to use trigonometry for those of you that are in grade 10 and have done trig. There's a bunch of you in grade 9 that probably haven't done trig. You can only use Pythagoras here. Go. Anybody watch Jeopardy? You should. Jeopardy makes you smart. It's kind of boring. My family doesn't really like watching it with me either because I know all the answers, or almost all the answers.
You watch that one Shaq show where he gets a bunch of family members to do a game, and then they try and guess. It's basically Jeopardy, but with the basketball player.
No. I watch Jeopardy. I watch Idiot Test a lot because I love Idiot Test. If you haven't watched Idiot Test, it's super funny. Okay, are we good? Can I find x here? Yes or no? Do I have all the information I need to find x right now? It's yes or no, man. Take a guess if you don't know. Or if you still need more time to figure it out, take your time. I'll wait another 45 seconds. My daughter started watching this show on Netflix, 100% Hotter. Well, it's like a makeover show, but it's British, so the people are really mean. Because in Britain, everyone's mean to each other, not like here. It's a pretty funny show.
Do they drink tea a lot?
No, not on the show.
It's not British.
It's British. You shouldn't stereotype British people that way, but they do drink a lot of tea. Okay, so yes or no, can I find x here? No, I cannot. A lot of people do a lot of things with this question. And they say, you can find x, Mr. Myers, you really can. But you can't. A lot of people say you can find x because a lot of people say, well, can't you do Pythagoras with 20 and 35 to find that side? Can I? Why not, Erlen? It's not a right angle triangle. Or it might be, but you don't know. Then a lot of people say, well, isn't 20 and 20 the same because this is an isosceles triangle? Is it? No, why not, Jimmy? Pardon me? Right. If I put these two symbols right here, that means those two angles are the same. Could I do this now? I could, couldn't I? Because if those two angles are the same, what do you know about this side and this side? That they're the same. So this would be 20, and I could do this, couldn't I? Right? What if I put a right angle thing there? Could I do it now? I could, couldn't I? What if I put this line here, and I put those two there? Could you do it now? You could, because what do those two signs mean? That these are both 10. Oh, sorry. I'm a liar. These two signs. Could you do it now? Okay, so I'm going to put that in there, and now tell me what x is. Because now you can do it. What's the first thing you would do with that 90 degree in there now? Somebody tell me their first step. Zach?
Find the length of the hypotenuse for the one triangle.
You would find this length
Yeah.
using these two, right?
Yes.
Now, is that a leg or a hypotenuse for the blue triangle?
It's a leg.
It's a leg, so I'm going to be adding or subtracting.
Subtracting.
So this side right here, which I'm going to call y will equal the square root of 35 squared minus 20 squared, right?
Yes.
And that will give me a number, whatever that may be. I don't know what it is. Why won't you slide? square root 35 squared minus 20 squared. 28.7, right? Now what are you going to do? Now you got to deal with the yellow triangle, right? What is that y in the yellow triangle? It's the 28.7. It's the hypotenuse, isn't it? So x is going to equal the 28.7 squared minus 10 squared. And then I would have the answer, wouldn't I? Pardon me? It's 28.7 again? X, okay. Is that okay? Square root of answer squared minus 10 squared. It's 26.9. So this is now 26.9. Is everybody cool? Now, does this make sense? If you did all this work, would you hand this in to me? It's okay, right? Both legs are shorter than the hypotenuse here. Both legs are shorter than the hypotenuse here. This is hand-inable, isn't it? Everybody agrees, yes? Because I'm going to give you a whole bunch of assignments that require you to do stuff like this, and a whole bunch of you are going to hand me in questions where you find a hypotenuse to be shorter than one of the sides. You are looking at me like, I would never do that, Mr. Myers. I teach 210 kids a year. It happens so much that I have to do this. So you may think you are not going to be one of those kids. But so many of my students hand me in work where they tell me this side is longer than the hypotenuse. It will happen. Now, let me ask you this. What would happen, do you think, to our answers if I changed this and I then told you these two were the same? Would that change our answers? Of course it would, because what does that make this line now? 20. 20 and 20. And then I would do Pythagoras here. Right? Is everybody with me? The point I'm trying to make with that is this. Does it matter what the drawing looks like? No. The drawing is designed to give you the information you need to do the math you need to do. Is everybody with me? The drawing is a guide. It is not to be taken seriously, except to say, okay, there's the hypotenuse, that's a leg. Is everybody cool? There are some times when that is not true, when the drawing is important. If that happens, I will let you know. I would never just expect you to know that the drawing is actually important. Does everybody get what I'm saying? Okay. Do the second one. Can you do it right now? And if you can, do so. Without using trigonometry, can you do B?
Yes.
How did you do B, Zach?
Find the hypotenuse of the first triangle and then use it to
You found that hypotenuse here? And then you did Pythagoras over here?
Yes.
Why? Are there any 90 degrees in that triangle? You're not in trouble. That's the whole point of this, right? That's the whole point of this. You cannot make assumptions, all right? If I put this here, is this super easy? If I put these here, is this super easy? If I put these here, is this super easy? If I put this here, is this super easy? That makes it kind of difficult, yeah? Does a little, doesn't it? Talk to your neighbor, see if you can figure this question out if you know that is 90 degrees, that whole angle. Go. All right, we got this one figured out. This one's a little trickier. You got to add a line to it. Does anybody know how to do it? Anybody figured it out? What if I gave you this line right here? Did I draw that line in? So since I drew it, I know it's 90 degrees, yes? Because if I had a protractor out, I could do that, right? Because we know this is 90, so these two lines have to be parallel, yes? So if I drop this line down here, how long is that? How long is it? 20. And if that part's 90, what's this part? 90. So can I do Pythagoras and get this side right here? I can, right? Now, if that's 20, then how long is this part? 10. So once I know that part, what would I do with 10 and that number? Add it together. Is everybody with me? The point I'm trying to make is you can do stuff to the drawings to make it so you can solve them. Is everybody good? Sweet. So if we were to do this, how would I find this part right here? That would be the square root of what? 25 squared minus 20 squared, because that's the hypotenuse, right? So that would be the square root of 625 minus 400, which would be the square root of 225, which would be 15, right? So this part would be 15, and this part would be what? 10, making this whole part what? 25. Now, we have done this work properly, yes? Is it possible that this whole side is 25 when this side is 25? Is that a possible shape in reality? Yes or no? No, it's not. It can't happen, can it? Right? Or can it? What did I just say about the drawings? They're not accurate. Right? So would this be allowed? Would you hand this in to me? Yes, because your math is sound. Does everybody understand? Okay? All right. Let's move it along. turn on to page 49. Now, listen to me, please. If you have a ruler, then I want for you to measure all 6 sides on here. If you have a ruler. If you don't, I just had a ruler. Thank you, Avian. I'm going to measure them right now so you can see good proof of it. That side is 9. Does everyone agree? 9. How long is that side for me? 4.5. And that side. What's that, about 7.3? Okay, let's call it 7.4. Are those accurate measurements? Or are they accurate-ish? They're accurate-ish, right? This is hardly a precision measuring device, and I'm just throwing it down there, yeah? Okay. Then this guy is about, what, 14? 14. This guy is about 7.2. Are we happy with that? And this guy is about 11.5. Are we happy with those measurements as accurate-ish? Everyone saw me do it, right? All of us have the same measurements. If you're measuring this yourself, you're going to have something close to that. Everyone agree? All right. So I'm going to go back to the computer screen, and we're going to talk about that. So we've already said that guy was 9, that guy was 7.4, that guy was 4.5. Down here, I'm going to shrink that view down to 125. Down here, we had 14, 11.5, and 7.2. All right, now, we got to do some talking about how triangles work. This is not, there's no reason for this, it's just what math guys have decided on. Some of you will have seen what I'm about to do before, some of you won't. I apologize if you've seen it before, but I want to make sure we're all good. Angles are labeled in caps. So A, B, C are the angles. So this triangle, and I should have written that in blue. I'm sorry I didn't. This triangle is triangle A, B, C. Everybody cool? Okay. This angle right here, which I'm going to highlight in yellow, has 3 different names. One of the names is angle A. The second name is angle CAB. And the third name is angle BAC. What's common to all of them? A. The corner of the angle is the important spot. Everybody good? So what are the 3 names for this angle up here? Angle C, angle BCA, and angle ACB. Is everybody good? We can all label and read the angles off a triangle, yes? You go from point to corner to point, or just the letter from the corner. Is everybody good? Okay. So everybody should be able to tell me the blue one as well. It is angle B, or angle ABC, or angle CBA. Yes? Okay. Don't write down what I'm about to write down. I just want to make sure of something. Do not write this down. D. Oops. What is the one of the three-letter names of that angle? There's two ways to name that angle with three letters. Give me one of them. With three letters. Other one. So Zach says BDC. Is that okay? BDC. Is that good? It's not going? Thanks. Is BDC okay? Okay, what's the other one you could name it? Nope. CDB, because I want to be on this side of it. Everybody understand? ADB would be over, ADC would be over here. Everybody cool with naming angles? Because it's really important for trig that you can read an angle both ways. Everybody's good? Okay. Okay, next thing. We've talked everything there is to talk about angles, right? Triangle has three angles. What else does it have three of? Sides. Sides are labeled in lower case. The sides name is the lowercase letter of its opposite. What does opposite mean in trig? What does opposite mean in trig? Across. So a side gets named for its opposite angle. So this here is a side, right? What letter would I give right here? Little f, because it's across from big F. Does everybody understand? So what would this side be? Lil d. What would this side be? Lil e. Everybody understand how to name triangles? Yes? Everybody is good? All right. Now, turn the page over. Fill in these 6 boxes. And then once they're filled in, fill in the green boxes. Go. If you don't remember or you didn't write down the distances, there they are. Just to help you out, what is this side right here? Lil A. What is this side right here? Lil C. What's this side right here? Little b. Fill in those 9 boxes, please. How long was little a? 4.5. How long was little b? And how long was little c? 9. How long was little d? 14. How long was little e? 11.5. How long was little f? 7.2. Everybody good? Okay. Now let's do a division. A divided by f. 4.5 divided by 7.2. B and E, 7.4 divided by 11.5. C and D, 9 divided by 14. Now, four, .625, correct? 7.4 divided by 11.5. 0.643. And finally, 9 divided by 14. 0.642. What do you notice about all three fractions? They're all 0.6. Why aren't they exactly the same?
It's not exact measure.
Because I didn't use an exact measuring tool, did I? But this allows us to set up the fact that if I have two triangles and their angles are all the same, then this division is always going to be the same. So for example, if that is 8 and that is 12 and this is 4, I can now find out what that is because of what we just proved. 8 divided by 12 would have to equal 4 divided by A. Has everyone seen that before? Even the grade 9s? We all have. We all need to be on the same page before we go forward with trig. Does everybody understand that about triangles? If the angles are the same, which they were, we didn't measure them because we don't have a lot of time, but they were, then this is true. Everybody good? And then we would do algebra to solve this. There's a simple trick to remember, though. If 8, the smaller triangle's in the numerator, then you have to keep that all the way across. I could also have done this 12 over 8 equals A over 4. I could have done that too. Does everybody understand Pythagoras and similar triangles? Because there is no point going on to trig if you can't do these 2 pages. Yeah? Okay, so you have now, first break is at 9:15. It is 8:55. I want to give you 10 minutes to ask me at least any questions about measurement, okay? But I want you to do page 51 and 52, okay? I expect 51 and 52 done by 10:40. Okay? So if you don't get them done now before you start your test, when you finish your test, you work on these pages. Does everyone understand? I want these done by 10:40. If you want to not even look at these right now, you just want to study for your measurement test, that's fine too. You want to ask me questions about conversions or anything, that's fine too. This is your work time, okay? Your test is when you get back from the break. You will need a pencil because there is a Scantron card which cannot be filled out with pen. If you don't have a pencil, have no fear. I am aware of how great students are bringing their supplies when they are needed, so I have a 20-pack right here. Okay? Does anybody have any questions about what they're to be doing right now? Good. Do so.